Hello. Today I will be talking about episodic memory systems, mechanics, and deficits. So, just a brief overview of what we'll be talking about today. I would like us to understand different memory types, um, the examples and differences of these memory types, the specific definition of episodic memory. I would like us to understand memory systems, the neural architecture of these memory systems, the memory processing network. I'd also like us to understand memory mechanics, formation, consolidation, and retrieval process. And lastly, understand memory deficits, specifically confabulation. I would like us to be able to know causes, examples, mechanisms, and implications for everyday life. So jumping into the different memory types, there's short-term and long-term. We'll be focusing on long-term memory. Within the long-term memory, there's explicit and implicit. Explicit, also known as declarative. There's two categories of explicit. It's episodic and semantic. I have an image of tomatoes. Semantic knowledge is general facts and knowledge about the world. So I know tomatoes are often red, on vines, edible. Um, my episodic memory, which is personal events and experiences. When I was 9, I tried a cherry tomato for the first time. I gagged. Um, I don't like cherry tomatoes. Implicit memory, also known as procedural. I have an image of a man riding bicycle because these are skills, habits, conditions, things you don't have to think about, but just do. Okay, now going into memory systems, just a brief overview. We're going to be talking about the neural architecture of explicit memory. Um, just what are the regions involved, a basic overview of how they work and how they're strengthened and weakened. So the main regions we'll be focusing on today are the prefrontal cortex, which is circled here. Um, this is prefrontal cortex for memory, allows for memory monitoring and clarification, allows for the organization of the content. And we will also be discussing the hippocampus, which is circled in red here. This is a primary coordinator for conscious memory formation and also gives spatial and temporal context for experiences. Okay, jumping into the memory processing network, there's 3 stages: encoding, storage, and retrieval. Jumping into encoding. So the initial processing is in the hippocampus, which could be thought of as like a memory gateway. Uh, this process then leads to the prefrontal cortex, which receives this input from the hippocampus and figures out what's worth remembering, what's not. And then groups of neurons fire to create a memory-specific network in the hippocampus, making the memory encoded. And here I have a image, just a, a basic diagram of a basic model of memory. We'll be focusing, I mean, this is the biggest part right here, this encoding aspect. We also have retrieval here um, and consolidation, but um, this is encoding happens from uh, short-term memory to long-term memory. Going on to the consolidation and storage aspect. So initial memory traces are held by temporary synaptic connections in the brain. Um, Sleep replays these neural patterns, strengthens connections, and then memory shifts from the hippocampus to distributed cortical networks. This image in the upper left here, this is just kind of a basic um, uh, basic diagram showing the encoding to consolidation process where we have, sensory information, sensory buffers, um, gets encoded, and then the memory is consolidated outside of the hippocampus. In this bottom right image here, I have, we see the hippocampus is going to be in blue, and these red nodes are, you know, cortical networks in the cerebral cortex. Um, in in this figure A here, we see these red lines are connected to the um, hippocampus. Um, a lot of lines, and then in figure B, once connections are strengthened, there is no longer these lines connected to the hippocampus, and the memory is allowed to live on in the cerebral cortex. Okay, going into the retrieval process. So basically, a cue, which can be either voluntary or involuntary, triggers activation of the neural networks in the hippocampus. Once these neural networks are triggered, the prefrontal cortex directs attention to the relevant information and suppresses irrelevant information and distractions. Um, and then the hippocampus and the prefrontal cortex work together to reconstruct the memory. Okay. So confabulation, this is, now I'm going to talk about memory deficits, confabulation specifically. So what is it? Confabulation is characterized by erroneously, erroneously making statements um, believed to be true without the deception of lying. Um, there's four different types. Spontaneous, which is characterized by, or it occurs without any specific trigger cue. An example of this would be a person with Alzheimer's might start talking about a pet they don't own. There's provoked, which is often found in clinical settings. It's when someone is prompted to remember something, and then um, in doing so, they fill in the gaps with fabricated details. An example of this would be, asking somebody, "What did you do this weekend?" And they say, "I went fishing," when they actually stayed at home. Um, Momentary confabulation is brief, fleeting instances of false memories, often occurring in response to specific questions. So, an example of this would be a patient with TBI might, or traumatic brain injury, might briefly think a nurse is in their family, is their family member when asked who they are. Excuse me. And lastly, fantastic confabulation involves elaborate and often fantastical memories. An example of this would be a person with schizophrenia might claim to have traveled to another planet or to possess supernatural powers. Okay, causes of confabulation. So there are some diseases that are big predictors for confabulating confabulation. Korsakoff syndrome, which is occurs when drink too much alcohol, Alzheimer's, dementia, uh, forgetfulness, traumatic brain injury, and schizophrenia. Okay, so confabulation in the brain. The key regions involved are, like we mentioned before, the hippocampus and the prefrontal cortex, as well as the amygdala. So, damage in the PFC can lead to difficulty distinguishing between true and false memories. Um, and damage in the hippocampus can cause gaps in memory left to be filled with confabulation. And the amygdala disruption can affect the accuracy of the memories. Um, I have this image to the right of a road collapsing. I like to think of it as these connections, these memory paths we have are almost like roads. And um, when certain brain regions are affected by varying uh, diseases, uh, these roads get split. They get, cut up, moved, um, allowing for these memory connections to go all over the place or miss the actual information that the brain should be um, creating. So, what's the big deal when memory doesn't work? So, I mean, just some signs of memory deficit, frequent forgetfulness, difficulty with tasks, confusion, changes in mood and behavior. Um, these are all um, characteristics of memory loss, memory deficits, and these can affect uh, everybody in a variety of ways. Occupational safety, um, social life, uh, appetite. Um, it's it's not good when we can't trust ourselves, um, especially our memories. Some ways to protect. Protection is very important. Um, we should stay mentally active. Continue to stimulate your brain, whether it's word games like Wordle or the crossword. I think are good examples. Maintain a healthy lifestyle, exercise, eat a good diet. Um, Identify chronic conditions, understand if you have a history of illness in the family, recognize those illnesses uh, and understand them and be on the lookout. Socialize. I mean, this is this is important for many things just besides memory. But socialization is huge. Surround yourself with friends and obviously protect your head because traumatic brain injury is no good. Is my memory at risk? Um, I just wanted to leave with a question. I know sometimes I think my memory is kind of shot, um, but it's not the case. And we can always do more to uh, increase our memory and help our memories. But we should also be aware of the things that put it at risk. Thank you. Some learning objectives. So I hope at this end of the video, you guys will be able to understand the memory types and the associated systems, memory mechanics, memory types, deficits, specifically confabulation, and memory protection. Thank you.